This second method is going to be a little bit faster, I believe, and you can do whichever of the two you want. Basically, what we're going to do is we're going to draw these two vectors tip to tail. So I'm going to draw this one like that, and then I'm going to take the second vector and I'm going to go like this. The key here is this is 300. That is 60. Now remember, this angle in there was 20 degrees. And that angle in there, right in there, is 10 degrees. What that is going to tell you, and the reason I drew this right there, is inside here, right in there, that angle is 80 degrees. And if this were a right triangle, this would be 70 degrees. The bottom line here is this whole angle is 150 degrees. Now we've got this length and the angle in between. So now we can use the law of cosines to find that. We're going to call that magnitude of r, and that squared is 300 squared plus 60 squared minus 2 360 cosine of 150. And again, it's really important right in there to sort of draw a new set of axes to help you get those angles. If you punch this into your calculator and take the square root of all of that, you will again get our 353.2 degrees. Sorry, not degrees, kilometers per hour. Now, to find the angle, this is a little bit tricky. Inside there, in this triangle, let's call that theta. And you have to watch where it is, okay? I'm going to do law of sines now. Sine theta over the opposite side is 60 equals the sine of 150 over that side, which is the 353.2, and theta is going to be inverse sine of 60 sine 150 over 353.2. And you're going to get an angle here of 4.9 degrees. And you're thinking, like, that's not the same answer as before. But look where that angle is. It's the angle in that triangle. And I'm going to go down here and do this a little bit bigger. So this is the resultant. This is the initial, the first of the two vectors. And remember, that angle there is 20 degrees. This angle in there is 4.9 degrees, which means this angle right there, which is the one we want, is 20 minus 4.9, which is 15.1. And that's the same answer as before. So be careful, because when we solve for the angle here, it's the angle inside the triangle, and we have to then figure out what the angle is to there from that. So a little bit trickier to get the actual proper angle, but overall a shorter solution.